Welcome back to the Machine Learning series. In this episode, we're diving into supervised learning, what it is, how it works, and the most powerful algorithms you need to know. Whether you're trying to predict house prices, detect spam, or recommend products, supervised learning is the engine behind it all. Let's get started. What is supervised learning? Supervised learning is like teaching a child using flashcards. You show the system an input, like an image, and the correct label, like cat. The computer then learns from many such examples until it can predict new ones on its own. In short, it's learning from examples where both the question and the answer are known. 1. Linear regression, predicting numbers made easy. Linear regression is used when you want to predict continuous numerical values. Imagine you're trying to estimate someone's salary based on their years of experience. Linear regression finds the best straight line that fits the data. The equation is simple. Y equals mx plus b, where y is the predicted output, x is the input, m is the slope, and b is the intercept. It's most useful in tasks like predicting housing prices, forecasting sales, or estimating cost trends. It's simple and fast, but not great when your data is nonlinear or full of outliers. 2. Logistic regression, yes or no predictions. Logistic regression is a classification algorithm used to predict binary outcomes like yes or no, true or false. It works by applying a sigmoid function to squeeze predictions into a range between 0 and 1. If the result is over 0.5, it predicts yes. Otherwise, no. This method is used in spam detection, medical diagnosis, and predicting customer behavior. It's easy to interpret and efficient, but it assumes linear relationships and struggles with more complex boundaries. 3. Decision trees, the human-like algorithm. Decision trees break down problems like a human would, step by step, asking one question at a time. It splits the data based on feature values, like is age greater than 30. These splits continue until the model reaches a final decision or classification. You often see decision trees in applications like loan approval, medical diagnoses, and recommendation systems. They're easy to understand and explain, but they can overfit the training data if not carefully managed. 4. Random forest, when one tree isn't enough. Random forest builds on the idea of decision trees by creating a collection, or forest, of them. Each tree learns from a random subset of the data, and they all vote on the final prediction. This method helps reduce overfitting and improves accuracy. It's used in fraud detection, credit scoring, and product recommendation. The trade-off is that it's more complex and slower than a single tree. 5. Support vector machines, drawing the perfect line. Support vector machines aim to find the best boundary between two classes by maximizing the margin between them. Only the most critical data points, called support vectors, are used to define this boundary. If the data isn't linearly separable, the algorithm uses something called the kernel trick to map it into a higher dimension. SVMs are especially good for facial recognition, image classification, and text categorization. They're powerful, but they don't scale well to large datasets and require tuning. 6. K-nearest neighbors, learning by example. K-nearest neighbors, or KNN, is a lazy algorithm. It doesn't learn during training, instead, it memorizes the data and makes predictions by checking which points are closest. If most of the neighbors are labeled yes, the new point is also labeled yes. You'll find KNN used in recommender systems, image recognition, and customer segmentation. It's simple to implement, but it's slow to predict and sensitive to irrelevant features. 7. naive Bayes, spam filters and beyond. Naive Bayes is based on Bayes' theorem and assumes that features are independent, which is rarely true in real life, hence the name naive. Even with this assumption, it performs very well in many real-world cases, especially with text data. This algorithm is used in email filtering, sentiment analysis, and medical classification. It's fast and effective with small datasets, but its independence assumption can limit its performance. 8. Gradient boosting and XGBoost. The ML champions gradient boosting builds models sequentially, where each new tree corrects the errors made by the previous one. XGBoost is an optimized, scalable, and faster version of gradient boosting that has won countless data science competitions. These algorithms are excellent for financial modeling, marketing optimization, and any task that requires high accuracy. They are extremely powerful, but can take longer to train and require careful tuning. 9. Model evaluation and tuning. Making your model better. Building a model is only half the battle. You also need to evaluate its performance and fine-tune it for better results. For classification problems, you'll use metrics like accuracy, precision, recall, F1 score, and ROC AUC. For regression problems, focus on metrics like root mean squared error, mean absolute error, and R-squared. To tune your model, start with train test split or cross-validation. Then, use grid search or random search to explore different hyperparameters. Tools like scikit-learn's grid search for OpTuner can help automate the process. A quick tip: always evaluate your model on unseen data to avoid overfitting. So, what's the takeaway here? You don't need the most complicated algorithm to solve your problem. Sometimes, a simple logistic regression model, if properly tuned, can outperform a poorly trained XGBoost. The key is to know your data, understand your goals, and apply the right technique accordingly. Outro, spoken directly to the audience. Thanks for joining me on this deep dive into supervised learning. If you found this helpful, hit like, subscribe, and turn on notifications so you won't miss our upcoming episodes on unsupervised learning, deep learning, and beyond. Keep learning, stay curious, and I'll see you in the next one.